Okay, so to continue on with section 2.5, I just want to do two examples. Alright, so we were talking about the conditions where a horizontal asymptote occurs that hopefully you remember from pre-calc. Now I'm going to show you the calculus way to find that asymptote. So here our example says, describe the end behavior of g of x. Hopefully you notice that g of x has the same degree in the numerator as it does in the denominator. So pre-calculus, we would simply take the ratio of leading coefficients and we'd probably be done. But in calculus, we want to be a bit more rigorous than this. So I'm finding the limit as x goes to infinity of my g of x here. And the method is that we divide out by the highest power of x in the denominator. Okay, I'm really going to show this. Whoops. Skipped ahead. Okay. So hopefully you can see that the largest powered term, or the largest power of x in the denominator, is x to the fourth. So we're going to be dividing every single term by x to the fourth. Oh gosh, I keep doing that. Okay, so we've got 40x to the fourth divided by x to the fourth plus 4x squared over x to the fourth minus 1 over x to the fourth all over 10x to the fourth over x to the fourth plus 8x squared over x to the fourth plus 1 over x to the fourth. Okay, so cleaning this up a little bit, we can cancel out some powers. We've got 40 plus 4 over x squared minus 1 over x to the fourth all over 10 plus 8 over x squared plus 1 over x to the fourth. Now if you recall from last week some of the limit rules, you are allowed to think of each of these terms separately and take the limit of each of these terms separately. Okay, so hopefully you can see that for this guy, as x gets very, very large, this term is going to go to 0. Same with this one, same with this one, and same with this one. So if we go ahead and take the limit, I'm going to go to the next page now, we will get 40 plus 0 minus 0 over 10 plus 0 plus 0, so 40 over 10, which is 4. So 4 is not only the horizontal asymptote, it's the limit as x goes to infinity. It is the end behavior. Alright, one more example. So this is a similar idea, but the algebra is a bit more tricky. Okay, so same thing. We're still trying to determine the end behavior. And we have this following function. Okay, so there it is. So you might be asking yourself, this looks nothing like what we just did. But note that in the numerator here, the highest power that we see is 9x squared. Okay, so an x squared. But that x squared occurs under a radical. So the square root of x squared really is like a power of x to the first. Okay, so we've got effectively a power of x to the first in the numerator and in the denominator. So this is a very similar case to what we just saw. So I'm going to follow the same method when I take the limit, and I'm going to divide out by the largest power of x in the denominator, which is just x. So we take the limit of our function, and so I'm dividing by 1 over x for everything, so that's going to looks like this. So, dividing by x of everything is the same thing as multiplying by 1 over x divided by 1 over x, which is really just a convenient multiplication of 1. So we go ahead and do that, and we get this expression. Okay, so, this term is going to go to 0. This term is going to go to 0. This term just stays at 1. The tricky part is what is going on with this term. It's still a little unclear, right? So what I'm going to do is I'm going to factor an x squared out of all the terms inside of the square root. So let me do that first. Okay, so factoring the x squared out of all these terms here gives us this expression, and now we can start to think about bringing the x squared outside of the radical. So recall that the square root of x squared is equal to the absolute value of x. So I'm going to bring that outside the radical, and we're going to get the following expression. Okay? So the limit as x goes to infinity of the absolute value of x over x, this guy right here, is just 1. The limit as x goes to infinity of 9 is 9. 3 over x is going to go to 0. 4 over x squared is going to 0. Minus 4 over x goes to 0. And 1 over x goes to 0. So that leaves us with 1 times the square root of 9 plus 0 plus 0 minus 0 all over 1 minus 0, which is simply 1 times the square root of 9, which is 3. So the other part of this problem in the homework was to take the limit as x goes to negative infinity. The only thing that really changes is this guy right here. Okay, everything else is going to behave the same. Now as x goes to negative infinity, the numerator here stays positive. The denominator is negative. So ultimately this is going to be a negative quantity. The magnitude of the numerator and denominator are the same, so it's going to go to negative 1. And so therefore, the limit of this function as x goes to negative infinity, I think it was f of x. Yeah, so I'll just write that. F of x has to be negative 3. Okay, so hopefully that clears some things up. Let me know if you have more questions.